definitely. And good that we are getting it recorded so that for those who are probably not able to join because of the work, at
Yeah.
least they will get a chance to revisit. So should I share my screen and we can get started?
Yes, you can
Yeah,
share. I stopped
sure. All
sharing.
right. Yeah, sure. Hopefully my screen is visible.
Mm-hmm.
All
Yeah,
right.
it
Okay.
is.
So let's
Perfect.
get started. All right.
Yeah.
All right. So hello everyone.
But your
And
camera is not
oh, camera is
switched
not
on.
on. Oh, yeah.
Yeah.
Thanks for that. All right. Hopefully it comes through. Yeah. All right. So hello everyone. Thank you very much for joining us today at the Global AI Days Bremen 2025 edition. Firstly, thank you very much to all of the organizers for putting this effort. And we are pretty much excited to showcase our session on unlocking the insights with GraphRAG, which is one of the smarter way to retrieve the information. So don't think like we are going to directly go into the GraphRAG. We will keep it pretty much simple. We will keep it to the basic so that we will understand the concept of RAG and then how we can use GraphRAG, which will help you to go beyond the expectation and probably retrieve the information in very simplistic way. So GraphRag is nothing but the graph-based retrieval-augmented generation, and this is kind of an exciting approach that combines structured data in the form of knowledge graph with the cutting-edge generative AI to deliver the smarter, more context-aware kind of a solution. And over the course of this session, we will explore its core principles, the components that make it work, the use cases, as well as how it can be implemented to solve the real world problems. And again, we are going to start with the basics. So before we get started, quick introduction. Myself, Nanddeep Nachan. I am from Pune, India. I am Microsoft MVP for M365 and AI platform, as well as Microsoft certified trainer and author of these three books that you can see on the screen. And as well, I do have my Twitter, LinkedIn handles, as well as my blog and YouTube channel. So feel free to get in touch with me, and we can get this discussion ahead there. And with me today is Smita.
Hello, myself Smita Nachan. I am from Pune, India. So greetings from Pune. I'm having total 16 plus years of experience in Microsoft technology. I'm a Microsoft MVP and I'm author of these two books. These are some of my social handles by which you can get in touch with me.
All right, so this is the agenda that we're going to go through over this session. So as I said, we will keep it very basic. We'll start with the basic. And firstly, like before we go with the agenda, let's say for example, when we are setting up our LLM or maybe whenever we are setting up our project into the Azure AI Foundry, which was formerly Azure AI Studio, the basic expectation is that when we ground our data, we want to get some good results. Okay, and there are various ways in which we will be able to do that. Firstly, like you can just work with the prompt engineering, have the good prompt written, and then again you are going to get good results. Secondly, like you can maybe fine tune your model so that it will be specifically trained onto the organizational or data on which you want to train it on, and then use that. And third approach could be RAG, which is a retrieval augmented generation. So what we are going to do is we are going to just flip the order and then we are going to look into the prompt engineering first, followed by the fine tuning. We'll be just touch basing on those concepts so that it will be clear to everyone. For example, if you are hearing it for the first time, and then we will understand the RAG, and from there we will see how graph RAG goes beyond that, and then we will be able to build the knowledge graph around graph RAG. And again, we are going to take one example of contract documents, like how we'll be able to talk to those contract documents using graph RAG. But with that, let's get started and get introduced to the prompt engineering.
So, the prompt engineering refers to the practice of carefully crafting input prompts or the queries to achieve the desired outputs or the behaviors from these natural language processing models. So, particularly large language models like GPT. So, in the context of the language models, the prompt engineering involves the formulating the prompts that guide the model to produce the outputs that align with the user expectations or the requirements. So, this can be used to improve the relevance, accuracy, or the style of the generated content. So, some of the key aspects of this prompt engineering, the first one is choosing the effective prompts. So, the crafting the prompts that are clear, specific, and well suited to the task at hand. The second one is experimentation. So, iteratively testing the different prompts to observe how they influence the model's behavior and adjusting them based on the desired outcomes. The third one is understanding the model capabilities. So, the knowing the strengths and the limitations of the language model to tailor the prompts accordingly. And the fourth one, that is the context management. So, considering the context and providing the sufficient information within the prompt for the model to generate the coherent and contextually relevant responses. So, the prompt engineering is often employed in various natural language processing applications, including the chatbots, content generation, and as well as the text-based question answering system. So it's allow users to have a more control over the model's behavior and output and making the models more adaptable and useful for the specific task. So GPT-3, GPT 3.5, GPT-4 models are from the OpenAI are the prompt based. So with the prompt based models, the user interacts with the model by entering a text prompt to which the model responds with the text completion. So this completion is the model continuation of the input text. So while these models are extremely powerful, their behavioralism is also the sensitive to the prompt. So this makes the prompt construction an important skills to develop. So let's see what are these prompt components. So there are various ways to break down these prompts. The aim of this breakdown is to offer a straightforward way to understand how the prompts are made. So let's look at the components which makes a good prompt. So the first one is the instructions. So the instructions are likely the most commonly used prompt component. So the instructions are simply that the instructions to the model on what to do. So while simple in concept, they can be complex in practice. The second one is the primary content. So the primary contents refers to some sort of text that is being processed or transformed by the model. So the primary content is typically used in conjunction with the instructions. A simple example would be the language translation. Third one, for the examples. So the successful prompts often rely on the practice of one shot or the few shot learning. So this refers to the inclusion of one or more examples of the desired behavior of the model, so typically by including the input or output pairs. Then we have cues. So the cues acts as the jumpstart for the output of the model, helping to direct the model to the desired output. So it is often a prefix that the model can build onto. Then the last one is the supporting content. So the supporting content is the information that the model can utilize to influence the output in some way. So it differs from the primary content in that it is not the main target of task, but it is typically used along with the primary content. So with that, let's go ahead and check these prompt components in the chat completion API. So in a chat completion API, there are the distinct sections of the prompts that are sent to the API in the form of an array of dictionaries which associated with the roles. So all the components are optional, but at least one must be present and most prompts includes more than one component.
All right, so with that, let's have a look at very quick demo. So right now we are into the Azure AI Foundry, which was previously named as Azure AI Studio, which is right now rebranded to AI Foundry. So in here, right now we have made a deployment of GPT-4o, and during this session we are going to use this deployment itself. So here you can see that we do have this thing called as the model instruction. So this box contains the instruction. That means this one will create the behavior or define the behavior for your model. And then again, we do have other sections as well. For example, we'll be able to add examples or even variables. So let's say, for example, if we go with the example part, in this case, we will be able to define the user as well as the assistant part. Like user can define like what kind of an information user is looking out for, and then assistant can help with that. So in all, we will be able to define these prompt components in the chat completion API, and then from there we can move forward. But again, there are certain best practices to work with that. So let us go through those.
So here are some of the prompts best practices. The first one is the be specific. So leave as little to interpretation as possible. Restrict the operational space. The second one is be descriptive. So use analogies. The third one is the double down. So sometimes you may need to repeat yourself to the model. So give instructions before and after your primary content. Use an instructions. The fourth one is the order matters. So, the order in which you present the information to the model may impact the output. So, whether you put the instructions before the content, let's say summarize the following things, or after the content, for example, summarize the above things, can make a difference in the output. So, even the order of a few short examples can matter. So, this refer to as a recency bias. So next one is give the model an out. So it can sometimes be helpful to give the model an alternative path if it is unable to complete the assigned task. Let's say, for example, when asking a question over a piece of text, you might include something like respond with not, for example, let's say not found if the answer is not present. So this can help the model to avoid the generating the false responses. So with that, let's go ahead and check this. What is the temperature and this topic parameters? Okay, so the changing the temperature parameter changes the output of the model. So the temperature parameter can be set between 0 and 1. A higher value, for example, let's say 0. 0.7, will make the output more random and produce the more divergent responses, while a lower value like 0. 0.2 will make the output more focused. A fictional story could be generated using a higher temperature, whereas to generate a legal document, it is recommended to use a much lower temperature. So another one is the topic parameter. So is another parameter that is similar to the temperature, but in that it also controls the randomness of the model response, but it does not so in a different way. So the general recommendation is used to alter one of these two parameters at a time, but not the both. So next thing is we are going to check for this fine tuning. So when to use this? What is the purpose of this? What is the prompts and what is the cons of this? So the fine tuning is preferable when you have a specific task or the domains that requires a specialized model behavior. So it is suitable for the scenario where you have access to label data related to the task you want the model to perform. So the fine tuning is effective for achieving the high accuracy and the performance on the well defined task or the data sets. Let's compare what are the pros and cons of this. So let's first go for the pros. So results in the models that are tailored and optimized for specific tasks or the domains leading to improved performance metrics. It allows for precise control over the model behavior and outputs by fine tuning its parameters on the relevant data. It can be used to address the domain specific challenges or requirements by adapting the model to the targeted domain. And let's go with the cons. So it requires sufficient label data for fine tuning, which may not always be available or easy to obtain. So these fine-tuned models may exhibit bias present in the training data, leading to potential fairness and ethical concerns also. So, this fine tuning can be computationally expensive and time consuming, especially for the large model and the data sets. So, let's go ahead and check for the RAG approach. But before that, let me provide you some of the summary for this one. So, in summary, the prompt engineering provides a structured approach to guide the language models, while the RAG and the fine tuning offer specific methods for enhancing the model capabilities in a different context. So, the choice between these methods depends on the factors such as the availability of the external knowledge, the specificity of the task or the domain, and the desired balance between the model flexibility and the performance. So now let's check for this RAG. So RAG is the retrieval augmented generation in Azure AI search. So this retrieval augmented generation is an architecture that augments the capabilities of LLM large language models like a ChatGPT by adding an information retrieval system that provides a grounding data. Adding an information retrieval system gives you the control over the grounding data used by the LLM when it formulates a response. So, for an enterprise solution, RAG architecture means that you can constrain the generative AI to your enterprise content source from the vectorized documents, images, audio, as well as the videos. So, at its core, the RAG addresses one of the biggest challenges in generative AI, so, factual consistency. So, instead of relying solely on the model training data, RAG retrieves the relevant information at runtime from the external sources, ensuring the responses are more accurate and grounded. So, let's see for this when to use these RAGs, what are the pros and what are the cons for this one. So when to use RAG? So RAG is suitable when you want to enhance the model responses by incorporating the external knowledge or the information retrieval. So it is useful for the task where the context from the external sources is crucial for generating the accurate responses. RAG can be employed in scenarios where you need the model to provide a diverse answers based on the retrieved information. What are the pros for this one? So it enables the model to generate the more informed and contextually relevant responses by leveraging the external knowledge sources. It also provides the flexibility in incorporating the various type of information retrieval method such as the structured databases or unstructured text corpora. So it helps in improving the accuracy and comprehensiveness of the model's outputs by supplementing its internal knowledge with the external data. So this we had discussion about the pros. So let's go ahead and check what are the cons. So it requires the additional computational resources and infrastructure for information retrieval and the integration with the model. So you may introduce noise or bias from external sources into the model responses, affecting their quality as well as reliability. So designing the effective retrieval strategies and integrating them seamlessly with the model can be the challenging over here. Now let's see with the demo.
Alright, so with that, let's get into a simple demo how you will be able to create your RAG pattern. Alright, so what I've done right now is that using ChatGPT, I have created few fictitious contracts. So let me just pull one onto the screen. Alright, so here is the one. So here is the contract agreement between two parties, for example, Alpha Tech Solutions and Beta Corp. So this defines the scope of the agreement, terms and renewal, like when it is expiring, and then what is the pricing and payment terms, as well as other confidentiality, termination, laws, notices, and other sections. The main information here lies on which are the parties which are involved here when that particular agreement took place, and then again until when this is going to be valid. So there are almost 20 documents that I have generated with that. And now that let us try to build the RAG pattern, try to understand what are the limitations that we get, and then from there, how GraphRAG help us to find out or maybe filter out those kind of limitations. All right, so let me again go back to the AI Foundry or Azure AI Studio in the past. So this is the place, and from here we have done the deployment of GPT-4o, and from here we will be able to bring our own data. So there are various data sources available from where we'll be able to bring the data. Simplest one is obviously by uploading the files, but to do that you will obviously need blob storage as well as AI search so that those files which are uploaded being stored to the blob storage, and then again the index can be built on it using Azure AI search. Or for example, if you already have Azure AI search and index built from there, you can use Azure AI search directly, which we are going to do right now. And again, we do have blob storage, Cosmos DB, Elasticsearch, as well as the URL or web address from where we'll be able to ground up our data. So earlier, like I had used this option to upload the files, and then I have selected the blob storage and AI search, and I have already created the index to save the time because it generally takes at least 5 to 7 minutes to get that index created. So approach is pretty much simple. We have selected the upload files, we have selected our blob storage account, and then also selected the AI search account, and then we we just name that index, and that's it. We uploaded the files, and from there we went for creation of that index. So what I'm going to do right now is that I'm just going to reuse the same index which I built earlier. So I'm going to use the option of Azure AI search, and then this is the AI service, AI search service, which I have configured. And then contracts is the Azure AI search index that I have built into. For example, if you have got custom field that you want to map, for example, if you want to map the contract names maybe to some other entity, you can do it from here. We'll go to next, and here we get the search type. So keyword search here is the very basic search by which, for example, if there is a keyword to keyword match, we are going to get the results, but we will go for semantic search. That means these are the vector based search from where we'll be able to get the information by looking at the vectors. And again, we can do the search configuration. Right now, only default option is available. Let us go next, and we get an option to get ourselves authenticated to the Azure resource. For example, if you have the manage identity created, you can use that. At this point of time, I do not have, so I will go with the API key, which comes by default with the Azure OpenAI. And then let's click next. And what it should do is it should just import that index from the Azure AI search. So this is the information that we get, and click save and close. That's it. So now that we are pretty much ready inside of this AI Foundry chat playground to, to work with our contracts. So what I'm going to do is, so this is the index that we have got. So based on this index, it is going to give us the results. So the first question that I will ask, like, tell me about the Gamma Soft contract, because out of those 20 contracts that I have generated using ChatGPT, I know there is one with the name of Gamma Soft. Okay, so it will go ahead, and then it is giving us the result. So one way to rely on this kind of an results is with the citation. So here you can see that we do have the citation, and here is the reference of that PDF file which contains the information about the GammaSoft contract that we have got. All right, so this gives some kind of an authenticity or proof or more confidence to our users that they are getting the information from the trusted sources. Now that, for example, if we go ahead and we give other query or other prompt, when does Omicron contract ends? So again, it is one of the contracting party that I have got into my fake documents, and then it should be able to get the data from there. And here, from here, you can see that it is ending on 8th of March 2025 with the reference of that document. Now that, for example, if we go bit fancy and we try to ask the holistic kind of questions like how many contracts are ending in the year 2025. So at least since I have made those documents myself, so I know that there are many. And since we are using this power of GPT-4o, let us try to see what kind of information that we get. For example, if you can try this with GPT 3.5 or GPT-4, most of the time it fails. Although GPT-4o with its built-in knowledge and more processing capabilities, it is getting to the two references. So that is bit of correct. Like there are those contracts which are ending um, on 2025 and 2026. But again, I know that there are more contracts than this. So somewhere this rank pattern is unable to get the holistic view, because what happens is like it has generated the index. So that index can only look into the data onto which it has been indexed, and it can give us the information based on that index itself. But for example, if you ask a holistic kind of a questions of which the information is not directly available in the index, it can just use the power of GPT model that we are using, and probably it may or may not give you the correct result. Let's say, for example, if we again go with other question like how many contracts are active, then let us see what kind of an information it gives. So again, it is just giving me three active contracts, but I know that there are more than that. And last question probably we can ask like how many total contracts do we have? So in this case, it tries to get that information, and let us see, because we know that we have almost 20 contracts in the index, but in spite of that, it is just giving only four contracts. It could be because there is a name contract mentioned somewhere in the document, but this is not probably a correct or accurate holistic information that we are looking out for. Now that this is the limitation or maybe some kind of an intelligence only used by the GPT-4o, which is able to answer those questions. But now that let us see like what is meant by GraphRAG, and then how we'll be able to use GraphRAG. So firstly, the traditional RAG that we just have seen, it often uses the unstructured or semi-structured kind of a data, such as plain text, which can lead to the shallow context retrieval. And this is where GraphRAG offers a significant advantage that we are going to see very shortly. All right. So let us come back to this GraphRAG. So we do have this GraphRAG, and we are going to see like what is GraphRAG, how, why do we have GraphRAG, and what is the core idea behind that. So graph-based RAG, that means graph-based retrieval-augmented generation. It leverages the knowledge graph that we have got for retrieval, and it augments the responses with interlinked and that structured data. So GraphRAG is a smarter and more organized way of doing the RAG. Unlike the simple method that rely on searching the plain text kind of a snippets, GraphRAG creates a structured knowledge graph from the raw text, and it organizes this graph into communities or groups, and then from there it summarizes this group and then uses this structure to make RAG task more efficient and more accurate. So this GraphRAG builds on the principle of RAG itself by introducing the knowledge graph as the data sources for the retrieval. So the knowledge graph organizes the information in a structured, interconnected kind of a way, with entities presented as a node and their relationship as edges. So this allows us to retrieve highly relevant and contextually rich kind of a data. So imagine querying a graph where you can traverse relationships like causes, traits, or even belongs to uncover the deeper kind of an insights. And then by augmenting the generative AI models with this kind of a structured data, we can achieve the outputs that are not only accurate but also contextually deep, and those are meaningful. Now that probably let us compare this traditional graph rag with baseline with the graph rag. Okay, so graph rag versus that baseline rag that we have got. So obviously graph rag is a game changer, but let us discuss out the baseline rag first. So baseline RAG or the traditional RAG that we have got. So this approach improves the LLM outputs by pulling the real world data using vector similarity searches that we just have seen. And it is useful for private data sets that LLM has not been directly trained on. and the things like company research documents or communication kind of a thing. But on the other hand, it has some major limitations. For example, it struggles to connect the information that is spread across multiple sources. So, for example, it will be able to get the information from multiple documents based on the index that it has got, but probably the baseline rank will fail to interconnect that information. Whether those two documents are connected to each other in any way, probably that kind of information it will lack. So if a question requires linking the disconnected pieces of the data through shared attributes, baseline RAG often fails there. So it also does not handle the large data sets or even complex documents as well, and it lacks the ability to provide the holistic or summarized kind of an understanding. So then we have our hero GraphRAG, and how does it fix that? So GraphRAG uses LLM to create knowledge graph from the input data and organizing that into the nodes, we call it as entities, and then edges, we call it as a relationship between those nodes. So these graphs are structured into communities or group, and then summaries are generated for each of the group. So at a query time, what GraphRag does is it leverages this structured graph and it summaries to enhance the prompt, making the answer more accurate as well as insightful. So why should we go for GraphRag? Because GraphRag performs exceptionally well in cases where baseline RAG struggles, like reasoning across multiple data points or maybe providing the deep understanding of complex kind of a data sets. And GraphRAG also demonstrates the level of intelligence and mastery that baseline RAG probably cannot achieve, especially when we are dealing with proprietary or private kind of a data sets. So by using the knowledge graph and structure reasoning, GraphRAG represents the significant step forward in how we can augment the generative AI with real world kind of an information. So now that, for example, if you want to know more about GraphRAG, you can just search for GraphRag into your favorite search engine, and then you should be able to go to the microsoft.github.io/GraphRag. So these are the knowledge graph which I was talking about. So all those dotted things that you see here, those are nothing but the knowledge graphs. And here they have very good documentation about how you can get started with GraphRag. They have a comparison which we just have talked about GraphRag versus the baseline RAG and how the GraphRag works, what is the architecture of that. So we are just going to look into that in a quick and then we will move for the demo. So these are the key components of GraphRag. So first we have the knowledge graph, which act as the structured database. The nodes represent the entities while the edges define the relationship between them. And then we do have those knowledge graph. Next that we do have graph retrieval mechanism. So which can be used or which mostly uses the methods like breadth first search or maybe depth first search or maybe any kind of an advanced techniques like graph embedding to find the relevant information, and that is where it stand out from the baseline rank. And once the data is retrieved, it passed to the generative AI model like GPT, specifically GPT-4 or GPT-4o that we can use in these cases, which uses the information to create the outputs. And then finally, there is a augmentation process that ensures that the AI output is enriched with the retrieved graph data, making it both accurate as well as insightful. Because when it will give us the data, that data will be in the form of chunks. So this GPT model will help us to get together those chunks, create the relevant information, and then send it out to you. Now that when we are working with GraphRag, there are various uh, depth in which we'll be able to query the information. So there is a query engine, which is the retrieval module of the graph RAG library, and it is one of the two main components of the RAG gallery. So the other one is obviously the indexing pipeline, which will help us to index the content. So we do have local search. So local search method generates the answers by combining relevant data from AI extracted kind of a knowledge graph with the text chunk from raw documents. So this method is quite useful for the questions which require understanding of a specific entities mentioned in the document. For example, what are the healing properties of chamomile? So probably that could be one of the questions that we can ask. Now that, for example, if we talk about global search, so global search method generates answer by searching over all AI generated community reports in a map reduced kind of a fashion. So this is a resource intensive method, but often gives good responses for questions that require understanding of the data set as a whole. For example, what are the most significant values of the herbs mentioned in this notebook? So it can give you that information. Then we do have the drift search. So it introduces a new approach to local search queries by including community information in the search process. So this expand the breadth of the query's starting point and leads to the retrieval and use of far higher variety of facts into the final answer. And then we do have the question generation. So this functionality takes a list of user queries and generates the next candidate question. And this is probably useful for generating the follow-up questions in a conversation, or maybe generating a list of questions for investigator to dive deeper into the data set. All right, so with that enough talking, let us go into the demo and see how we can create the graph RAG and then how it can help us to holistically answer the questions based on the data set that we have got. Again, we are going to use the same PDF files or contracts that we have got. And then again, also we will see what are the limitations of that approach as well. For example, whenever you are starting your journey with GraphRAG, you can simply go to this getting started and all of the instructions are mentioned here. Firstly, that you will have to install this GraphRAG using this command pip install GraphRAG, which I already have done. Second thing, what we need to do here is that we'll have to create our input folder, and then once we have the input folder created, we'll have to add all of the data into that input folder, and then we'll have to build index on top of that. So for that, let us go into demo environment. Let me go back here. So this is the empty folder that I have got. What I'm going to do here is that I'm going to create a folder called as rag test, and then inside of that rag test folder, we have got the input folder. So this is the input folder that we have got, and then all of the information in this input folder will be indexed. So what I'm going to do is that I already have those files converted to the text format, because as we are talking through the advantages or benefits of using GraphRag, there is a bigger limitation at this moment is that it only works onto the text files. It cannot understand the Word or PDF files. So just in case, for example, if you have got Word files or PDF files or even OCR kind of a documents, you will have to get them converted into text files. This is one of the biggest limitations that we have got working with GraphRag. Now that what we have here is like we do have created our input folder. That input folder contains all of the text files that we want to get indexed. So the next step for us is to go ahead and run the indexer. Okay, so for that, like we will have to create the index and then we will have to run the index. So to set up all the variables and everything, we will have to run this part. So once we will run this particular statement, it is going to create two files for us. First one will be env file, which will contain all of the environment variables, wherein we can put the graph API key and everything. And second thing will be our settings YAML, which contains the settings for our pipeline, and then we'll be able to update those files as we go. So let us go into our demo environment again and run this um, GraphRag init and then rag test. Once it is done, let me open this particular thing into Visual Studio Code so that we'll be able to understand it better when those files will get created. So right now this is just going ahead and setting up those two files for us. Okay, it is taking some more time than the usual. Mostly the demo times are not good. All right, so what probably I will do is until this one is loading, probably I can open my existing solution into Visual Studio Code so that we can save some time and then even we'll be able to run it directly. All right, okay, it is still running. Okay, usually it doesn't take that much of time, but looks like demo time. It doesn't like live demos. So this is the env file which we were talking about. So here we do have this graph API key. Don't worry, after this demo, I'm going to change that or shuffle that. So even if you note it down, it is not going to work. So this is the API key that we are going to use, which you can get directly from your Azure OpenAI. Second thing is the very important thing called as settings.yaml. And in this, we have got two things. First one is we need to specify our large language model. So the model that we can specify here, for example, we do have this GPT-4o model. And then again, this is the API base that we are going to use for that. And then we do have the API version associated with that. And this is the deployment name called as GPT-4o. For example, if you want to go into more depth level, you can also define the maximum retrieve wait time, as well as maybe top P or number of completions to generate and everything. You can specify all those parameters. The second thing that is more important here is about embedding because it will create an embedding based on the information that we have got into those text files. And then here we are going to use the LLM model again for the embedding. And in this case, we're going to use text embedding 3 small. So we can specify that value. And again, since it is in the same environment or same as registers, it is going to share that same API key here. Again, feel free to configure the other things like tokens per minute, request per minute, max retries and everything. You can do that. Once you are done with that, the next thing will be to generate the index out of it, which is a pretty much important step. So once you're done with that, what you need to do is you will have to go ahead and run this command GraphRAG index hyphen root and rag test. So probably let's try to run this here and let us see how does this work. Sorry, I guess this is the one that I'm going to show. Yeah, all right. This is the one that I'm going to show. All right, so we will go ahead and run this index. So when the index will be run, it will take some time so that it can go ahead and create, use that embedding model to generate the knowledge graph. Because now that we are talking about all of the nodes as well as the relationship, so it will take some time to do that. I think I ran it on the wrong window. Let me again go back, or let me just close all those things and let me start from scratch. Just give me one moment. I'm going to go into my GraphRAG demo. Okay, this is the one that I already have it built. So let me go here, open that into the PowerShell. Okay, and then again we are going to go back here and we're trying to run this. So based on all of the LLM models that we have specified here, it is going to create that index for us. Now that while it is running, let us go here. So for example, this is the input file wherein we have specified all of the text files based on which the index should be created. Secondly, we do have logs file. For example, if something goes wrong, if it is not able to generate the index or if there is any kind of an error, we can go into these logs and have a look at that. So right now, by luck, everything is working fine. All of the workflows have successfully completed. But again, for example, if you want to go into those logs and try to see what has happened in the background, you can do that. Then we do have this output folder, which is pretty much important because here you can see all those Parquet files are being created, and this is used by GraphRAG to answer all of the questions between those node entities and the relationship between those. Okay, so all of those groups, communities which we were talking about so far, you are able to see from here. And again, we do have those database files, large database files, uh, with which will GraphRAG will be able to answer our queries. All right, so that's it. With this, we should be able to go ahead and run our queries here. Okay. So what I'm going to do now is that same kind of queries that we had asked before, we are going to ask here as well. So firstly, like let's say we are working onto this data set, but we are not pretty much sure like what is the top theme in this story. So we'll just use this GraphRAG query with the root as the RAG test, which we have mentioned here. And then method we can specify as the global one. So global, that means it will give us the holistic information about all of the contracts that we have got. And then we are asking the query like what are the top themes in this story. So it will go ahead, it will try to get for that information using the knowledge graph that it has built into, and then we should be able to see the result here. Okay, so from here you can see that it was able to give you the entire information or entire story about this. Like this, the data set reveals the several interconnected themes that highlight the complexity and strategic importance of relationship, locations, and everything. That means it is talking about all those contract agreements that we have got inside of that, and it is giving the entire story of that. Now that, for example, we go ahead and try to ask the information about the how many contracts are active as of 2025. Again, we had asked these same questions when we were using the RAG pattern, and probably we just got to the three as the answer, only three contracts being active there. But let us see like what kind of an responses that we get with the graph RAG here. So the query is still running. We have used the method as local so that it can go to each of the contract and try to get the information from there based on the knowledge graph that it has built for various contracts that we have got. And then here we do have some more number of contracts, which is a correct result. So previously we got only three active contracts, and these are the references. But since I know that I have created these contracts, so we have got in total eight contracts which are active as of 2025, and this is the list of all those contracts. So that way, at least GraphRAG will give you more flexibility so that you will be able to deep dive more into your data. So for example, if the information is just within the document that you want to look into, in that case, definitely you can go for the baseline RAG pattern. But for example, when you are working onto the knowledge graph level, when you are trying to get the information by connecting those two dots together, obviously GraphRAG will help you better there. So then, coming to the closer of this session, like why should we choose GraphRAG? So the key kind of a thing lies here in the ability to provide the richer contextual understanding of the data. So the traditional RAG relies on the flat documents or unstructured kind of a text, but the graph RAG taps into the interconnected nature of the knowledge graph, which makes the retrieval of the data much more meaningful. And moreover, the knowledge graphs can be updated in the real time, ensuring that the system always works with the latest information. And this makes GraphRAG particularly suitable for scenarios where data is relational or requires the deep contextual kind of an insights. For example, healthcare, legal research, or enterprise knowledge management. Then what are those use cases in which we'll be able to implement GraphRAG? So GraphRAG is obviously versatile with the applications across the industries. And for instance, in healthcare, it can synthesize the treatment plans by analyzing the relationship between disease, symptoms, as well as the medications. In education, it can support the personalized learning by retrieving the curriculum specific data. Maybe in the enterprise knowledge management benefits from GraphRAG ability to summarize the reports or maybe provide the actionable kind of an insights. And similarly, for the customer support bots, they can leverage the product knowledge graph to offer the accurate solution. And as well for the legal and compliance kind of a team, they can rely for the retrieving kind of an cases for the law as well as the compliance rule. So each use cases underscore the potential of the GraphRAG to solve the complex as well as the real world challenges. But while we are talking to GraphRAG, there are two bigger limitations that we have highlighted in this demo. First thing is that it only works onto the text information. So for example, if you have got any images, those images needs to be converted via OCR into the text data, as well as for example, if you have used data maybe into the contracts format, then yes, obviously there is no other option but to get them converted to the text file. The other bigger kind of limitations that at least I have observed personally working with the GraphRAG is, let's say for example, even one or two lines of statement gets changed in any of the single document, we'll have to rebuild the entire index. So that means we'll have to go back, we'll have to upload that information, and again we'll have to run this command to re-index our entire data. Okay, so that is one of the limitation that we have got. So, but for example, if you are ready to sacrifice for those two limitations, but use the knowledge graph being used by the GraphRAG, in that case, GraphRAG is a best choice. All right, so I guess that was all we wanted to cover. So once again, thank you very much for organizing this event. Thank you very much for looking into this uh, session. And then, if in case you want to have more discussions around this topic, please feel free to ping us on uh, LinkedIn or onto blog or Twitter, and we are happy to take that discussion ahead. Thank you.
Yeah, thank you.